Hey guys, we're going to be working on 8-6 day number 2 in your note packets, where we're factoring completely still. Same as yesterday, just kind of making sure that we're good to go with this and using the factoring flow chart. So if you have your flow chart from a couple days ago or whenever, go ahead and get that out as well. So if you take a look at number 1, we've got p to the 5th minus p. And the first thing that you need to do for each of these is always ask yourself, is there a GCF? Well, there's certainly no numbers that I can take out because there's just one p to the 5th and minus p. But as far as letters go, these two terms share p. So I'm going to write p out front. And then when I do that, p to the 5th, but I factor out p, so I'm doing this like the GCF, that would leave me with p to the 4th. This is negative 1p. So I still have that negative 1 there, but p, take out a p. I don't have any letter p's next to that one. After you do that, factor out the GCF, you've got to check and see if it's a factor completely problem. So are there 4 terms? No way. Are there 3 terms? No. Are there 2 terms for this one? There are 2 terms left in those parentheses. I have p to the 4th and negative 1. So you have to see if that's a difference of squares. Difference means that you have to have a minus sign in there, in between your 2 terms. And we do have that, so that's a good thing. Then you check and see, is this a perfect square, p to the 4th? And that is, because p to the 4th can be split into p squared and another p squared. 1 is also a perfect square because if I do the square root of 1, it's just 1. So if you look at your difference of squares factoring flowchart, we're going to end up continuing with the 2 sets of parentheses. It ends up like being the same first and last thing in the parentheses, but one will always get a plus sign and one will always get a minus sign. So when I continue on with this, I'm going to keep that p that I factored out first, and then I'm going to set up my parentheses. And for difference of squares, one will always be plus, one will always be minus, and then I do the square root of this. So p to the 4th, that's going to split into p squared and p squared. 1, if I do the square root of 1, that's just 1 and 1. And so that is me being able to factor that completely. Now, if you take a look, I've got p out here. I can't do anything with that. P squared plus 1, there's still 2 terms there, but it's a plus sign in between. When it's a plus sign in between, it's not a difference of squares. You can't do anything with this set. If you look at your next set of parentheses, it's p squared minus 1. So this one is another difference problem because I have a minus sign here. P squared, that's a square. And 1, just like the one up here, is a square as well. So we can keep going with this set of parentheses right here. Everything else, the p and the p squared plus 1 is going to stay. But now, difference of squares again, I'm going to set up 2 sets of parentheses for this. And just kind of ignoring everything else, guys. 1 will get a plus, 1 will get a minus because it's a difference of squares problem. And p squared will split into p and another p. And the square root of 1 is just 1 and 1. And then if you take a look, okay, we already said we couldn't do anything with the p out front. We can't do anything with this one because it's a plus sign. We can't do anything with this set of parentheses either because it's a plus sign. And this is another difference problem, but p can't be split up at all. So p is not a perfect square like p squared is and like p to the 4th is. It can't be split up evenly. So then you are officially done with this problem. So this one you had to factor the GCF out first. You had a difference of squares, and then you had another difference of squares at the end there. So that one was kind of a tough one. It was like a 3-stepper. If you take a look at the next problem, number 2, got to look for a GCF first. That's always the top of your flow chart. So look at the numbers 2 and 18. 2 goes into both of those, so I'm going to take 2 out. X to the 4th, this one doesn't have any x's, so I'm going to write down what I'm left with here. If I take 2 out, that's going to leave me with x to the 4th plus 18 factor out of 2. That means 18 divided by 2, that's 9. And then let's see, if I follow my flow chart, after I take a GCF out, I'd have to ask myself, are there 4 terms? No. Are there 3 terms? No. Are there 2 terms? Yes, there is, but it has to be a difference of squares for that to work. And if you see, I have a plus sign there, not a difference problem. So it doesn't matter if this is factorable or if x to the 4th is a perfect square or if 9 is, because the plus sign totally ruins it for us. We can't go any farther than that. So that one you could just take the GCF out. Okay. Taking a look down at problem number 3, we've got 2x to the 4th minus 18. So really similar to the last one. 2 still goes into 2 and 18. I don't have any letters that I can take out, so that leaves me with x to the 4th. Negative 18 divided by this 2 is negative 9. This one, if I go to factor completely here, there's not 4 terms, there's not 3 terms, there are 2 terms, and it does have a minus sign. If it has a minus sign, then I just have to look and see, are these squares? X to the 4th definitely is, because that can split into x squared and x squared. And 9 is a perfect square as well, because the square root of 9 is 3. So this I can keep on going with. So I'm going to keep that 2 out front. I'm going to set up my difference of squares parentheses. One will always get a plus, one will always get a minus. X to the 4th splits into x squared and another x squared. And the square root of 9 is 3, so 3 and 3 go here. And then let's see, I can't do anything with the 2. This has a plus sign in it, and there's only 2 terms. It has to be difference for this to work for a difference of squares problem. This one does have a minus sign. And x squared is a perfect square, but 3 is not a perfect square. So there's just, we can't go any farther with that one at all then. So this is where you would stop for problem 3. One more to go, guys. Number 4, if you take a look, you've got x squared and minus 9y squared. And so if you take a look here, they don't have a GCF if you think about the top of your flow chart. There's not a GCF because x squared and y squared, they're not the same letter. So I can't take any x's or y's out. They don't share any. So if I go down the no arrow here from GCF, no. Are there 4 terms? No. 3 terms? No. 2 terms? There are 2 terms. Is it a difference problem? It is. So I just have to check and see if these are squares. X squared can definitely split into x and x, so that's a perfect square. 9 we just said was a perfect square earlier because the square root of 9 is a nice pretty 3. And even y squared can be split into y and y. So I'm going to go ahead and set this up as a difference of squares problem. One will always get a plus, one will always get a minus for the parentheses, and then I start my split here. So x squared will break into x and x. And then for this one, the square root of 9 is 3, so it's going to be 3 and 3 there. Y squared, though, is also there next to the 9. So that's going to split into y and y next to the 3's. And guys, remember, you can always FOIL your answer. And when you FOIL it, you'll get back our original problem. And I can't go any farther here because that's a plus sign with 2 terms. That doesn't do anything for me. Here, this one's a minus sign, but this is not a square anymore, and neither is 3 or y. So we're all set. This is the right answer for number 4. And that's all for notes today, guys. So now you know how to factor completely.